Ever wondered how power transmission lines withstand wind and other external forces? Today, we delve into the world of vibrations in transmission lines. Just like a guitar string, transmission lines can vibrate under certain conditions. Picture the wind sweeping across the conductors, much like a musician strumming a string. This can generate what we call aeroelastic vibrations. Similarly, when ice and snow accumulate on these lines, the weight distribution changes, causing additional vibrations. Imagine adding a capo to your guitar and you'll get the idea. These vibrations are more than just an interesting phenomenon. They are crucially important to the integrity of the transmission lines. If not controlled, these vibrations can lead to fatigue and wear on the conductors, hardware, and supporting structures. But how do we control them? Stay tuned to find out more about the solutions we use to keep these vibrations in check. So, what happens when these power lines start vibrating? Well, imagine the vibrations as tiny, invisible hammers. These hammers are relentlessly beating on the conductors, hardware, and supporting structures of the transmission lines. Over time, the constant battering can lead to fatigue and wear and tear on these components. The conductors, for instance, can become frayed and worn, increasing the risk of power disruptions. The hardware securing the conductors can also loosen over time, potentially leading to system instability. Even the supporting structures, such as towers and poles, are not immune to the effects of vibrations. They too can suffer from structural fatigue and possible failure if the vibrations are not properly managed. That's not all. In more severe cases, these vibrations can cause outright system failure. For instance, in extreme weather conditions, when wind-induced vibrations are coupled with the extra weight of ice and snow on the lines, the stresses can be significant. These conditions can lead to the snapping of conductors or the toppling of towers, resulting in power outages and costly repairs. But it's not just about the physical damage. Vibrations can also affect the electrical performance of the transmission lines. For example, the constant movement can cause fluctuations in line tension, which can impact the electrical characteristics of the line, such as its impedance. This can lead to power quality issues, such as voltage fluctuations or harmonic distortions. So you see, managing these vibrations is not just about preventing physical damage. It's also about ensuring the reliable and efficient operation of the power transmission system. As engineers, we need to understand these effects of vibrations and design our systems to withstand them. This is where dampers come into play. Dampers are like the shock absorbers in your car. They help to dissipate the energy from these vibrations and reduce their amplitude, thereby preventing excessive movement and potential damage. As you can see, vibrations are not just an annoyance, they pose a real threat to the operation of power transmission systems. Luckily, there's a solution to this problem: dampers. These ingenious contraptions are the unsung heroes when it comes to managing and reducing vibrations in transmission lines. Their role? To dissipate and control the amplitude of these potentially destructive oscillations, preventing excessive movement that could lead to wear and tear. Now you might be wondering, how do dampers do this? Well, it's all about energy absorption. When vibrations occur, they create kinetic energy. Dampers, like a sponge soaking up water, absorb and dissipate this energy, reducing the amplitude of the vibrations. But not all dampers are created equal. There are several types, each with its unique way of tackling the vibration issue. First up, we have Stockbridge dampers. These are the common folks in the damper world, often seen hanging out on transmission lines. They consist of a mass, usually a chunk of metal, suspended by a rod or cable. When the line vibrates, the mass swings, absorbing and dissipating the energy. Next, meet the tuned mass dampers. These are the specialists, designed with a natural frequency that matches the vibration frequency of the line. This precise tuning maximizes their effectiveness, allowing them to absorb a significant portion of the vibration energy. And then we have the friction dampers. These guys use friction between moving parts to dissipate energy. As vibrations cause the parts to move against each other, the resulting friction absorbs and dissipates the energy, reducing the vibrations. Each damper type has its strengths and applications, but they all share one common goal: to protect our transmission lines from the damaging effects of vibrations. So, whether it's a gusty day causing wind-induced oscillations or a heavy snowfall changing the weight distribution on the lines, dampers are there, working tirelessly to keep our power transmission infrastructure running smoothly. With dampers in place, the vibrations can be effectively managed. And that's a testament to the power of good engineering. But where exactly are these dampers installed and what benefits do they bring? Let's dive right into it. Dampers are not just randomly placed along the transmission line. Instead, their installation is a strategic decision made as per the specific characteristics of a transmission line. Typically, you'll find dampers at intervals or near critical points where vibrations are more likely to occur. This could be in places where the line is subject to heavy wind, or perhaps where ice and snow accumulation is a common phenomenon. Now, moving on to the types of dampers, there are quite a few. One of the most common ones is the Stockbridge damper. It comprises a mass, usually a metal weight, suspended by a rod or cable. The damper is placed on the conductor to absorb vibrations. Then we have the tuned mass dampers, designed to have a natural frequency that matches the frequency of the line's vibration, maximizing their effectiveness. And lastly, we have friction dampers that use friction between moving parts to dissipate energy and reduce vibrations. But what's the point of all this, you might ask? Well, the benefits of dampers are manifold. Firstly, by controlling vibrations, dampers help maintain the structural integrity of the transmission line components. This reduces the risk of fatigue and damage, thereby prolonging the lifespan of the transmission system. So, in a sense, dampers act as the guardians of your transmission line, keeping it safe from the damaging effects of incessant vibrations. Moreover, dampers can also enhance the performance of the transmission system. With reduced vibrations, the transmission lines are less prone to wear and tear, contributing to a more efficient and reliable power transmission. So, whether it's the Stockbridge damper, the tuned mass damper, or the friction damper, each plays a vital role in mitigating the impact of external forces, ensuring that the transmission lines remain secure and perform optimally. Dampers play a crucial role in safeguarding the integrity and performance of the power transmission infrastructure. So next time you see those little devices on a transmission line, you'll know just how important they are. Let's quickly recap what we've learned today. Vibrations in transmission lines are a common occurrence, brought about by various factors such as wind, ice, and dynamic loads. As the wind flows over the conductors, it can cause aeroelastic vibrations, leading to oscillations in the transmission lines. Ice and snow too have their part to play, altering the weight distribution on the lines, thereby contributing to vibrations. The implications of these vibrations are significant and far-reaching. They can cause wear and tear on the conductors, hardware, and supporting structures. Over time, this can lead to fatigue, damage, or even failure of these vital components. It's clear that vibrations are not just an inconvenience, but a serious concern that needs to be addressed. Enter dampers, the unsung heroes of the power transmission world. These devices are installed on transmission lines with a singular purpose: to dissipate and reduce the amplitude of vibrations. They control oscillations and prevent excessive movement, thereby playing a critical role in maintaining the stability of the transmission lines. There are different types of dampers, each with its unique mechanism and application. Stockbridge dampers, a common choice, consist of a metal weight suspended by a rod or cable, placed on the conductor to absorb vibrations. Tuned mass dampers, on the other hand, are designed to have a natural frequency that matches the frequency of the line's vibration, thereby maximizing their effectiveness. Lastly, we have friction dampers that utilize the friction between moving parts to dissipate energy and reduce vibrations. The installation of dampers is a strategic process. They are placed along the transmission line at carefully chosen intervals or near critical points where vibrations are likely to occur. This strategic placement ensures that the dampers are able to effectively manage and reduce vibrations, maintaining the balance and stability of the transmission lines. The benefits of dampers are manifold. They help maintain the structural integrity of the transmission line components, reducing the risk of fatigue and damage. This, in turn, enhances the performance and longevity of the transmission system. By mitigating the impact of external forces, dampers safeguard the integrity and performance of our power transmission infrastructure. In conclusion, vibrations in transmission lines are a significant concern, and dampers are our primary defense against them. These devices, whether they are Stockbridge dampers, tuned mass dampers or friction dampers, play a crucial role in managing and reducing vibrations. By doing so, they maintain the structural integrity of the transmission lines, enhance their performance, and extend their lifespan. The next time you see a power transmission line, you'll know what's keeping it steady against the forces of nature.